Copy 724, right. Center maintains 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
And this is going to be a short video. I wanted to talk about magnetic compass. So how does this magnetic compass work? So we have the magnetized needles which are fastened to a float assembly around which is mounted the compass card, and those needles, they align themselves parallel to the Earth's line of magnetic force. So the float assembly is housed in a bowl filled with acid-free white kerosene. That's how basically how the compass is made of and how how it works. The next thing is the limitations. Okay, so the limitations is like like um, the jewel and pivot type mounting allows the float freedom to rotate and tilt up to approximately 18 degrees angle of bank, which basically means that if you do a steeper bank angle, the compass indications are erratic and unpredictable. And the third thing I wanted to cover is the excuse me, the errors. So there are multiple errors, right? We can divide them in this category, that the oscillation, then we've got the deviation, then we have the variation, and last but not least is the dip, which is further divided into two things. One is acceleration error, and one is the northerly turning error. Okay, so what is an oscillation error? So the erratic movement of the compass card caused by the turbulence or rough control technique, that's the oscillation error. Deviation error, due to the electrical and magnetic disturbances inside the aircraft, and the error is called the deviation error. Whereas the variation error is the angular difference between the true and the magnetic north. Yeah. Now the dip errors are two, and they are kind of important. You should know those, especially the acceleration error. What happens is, like, if the plane is going on the east or on the west, right? West herrings. Uh, while accelerating, the magnetic compass shows a turn to the north. If you are accelerating, the magnetic compass will show you that you are turning to the north. Whereas if you are decelerating, the magnetic compass is gonna show you that you are turning to the south. So remember this acronym ANDS, ANDS, which means accelerate north, decelerate south. And the northerly turning error has another acronym. So what happens is, like, the compass leads to the south half of a turn and lags in the north half of a turn. So when you are going direction is north or south, the compass is gonna lead in the south, right, and it's gonna lead in the south and lags in the north half of the turn. So you can remember it by this acronym UNOS, UNOS, which means U is the undershoot. Let me just scroll down. UNOS. U is the undershoot, north, whereas overshoot when you are doing the south. Yep. So these were the things I wanted to cover. Thanks for watching.